In the cold expanse of space, more than 3.7 billion miles from Earth, a silent witness of human ingenuity floated on, a tiny spacecraft known as Voyager 1. Launched in 1977, its mission was clear: journey past the gas giants Jupiter and Saturn and send back data no human had ever seen before. But what no one could have predicted was how this uncrewed emissary of Earth would go on to redefine our place in the universe. As Voyager neared the end of its primary mission, astronomer Carl Sagan proposed something revolutionary. He convinced NASA to command Voyager to turn its camera around, not toward the vast cosmos ahead, but back toward home. The request was simple in action, but profound in meaning. It was a cosmic glance backward. On February 14, 1990, Voyager 1 snapped a photograph that would echo through history. Amidst the deep black of space, Earth appeared as a tiny speck, less than a pixel in size, bathed in a scattered ray of sunlight. This now famous image was dubbed the pale blue dot. In that image, suspended in a sunbeam, lay all of human history. Every person, every story, every dream, and every conflict. Earth, our only known haven, reduced to a microscopic fleck against the backdrop of infinity. Carl Sagan would later reflect, "Look again at that dot. That's here. That's home. That's us. The Earth is a very small stage in a vast cosmic arena." Voyager 1's journey didn't end there. Long after it completed its planetary tour, the spacecraft entered the realm of interstellar space, becoming the first human-made object to cross the heliopause, the boundary where the sun's influence ends and the interstellar medium begins. It continues to transmit data, whispering tales of the void, back to Earth across nearly 15 billion miles. What began as a mission to study planets has evolved into a voyage that challenges our understanding of space, time, and what it means to be human. The pale blue dot image remains not just a photograph, but a mirror. It reflects our fragility, our unity, and the staggering responsibility we have to care for this mote of dust suspended in a sunbeam. Voyager 1 and the 500 mysterious objects, a new cosmic enigma. Voyager 1, a name that echoes through the corridors of astronomical history, stands as one of humanity's greatest achievements. Launched in 1977, this spacecraft was designed to explore the outer planets, but over the decades, it has evolved into something far more profound, a symbol of our relentless curiosity and an ambassador of Earth to the cosmos. Against all odds, Voyager 1 continues to operate, more than 47 years after its launch, at a staggering distance of nearly 15 billion miles from Earth. Its instruments, though aged, still whisper back to us across the vast emptiness of space. Every signal it sends is a triumph of engineering and a reminder of humanity's reach into the stars. Throughout its journey, Voyager 1 has pushed the boundaries of what we once believed possible. It has not only revealed the secrets of distant planets like Jupiter and Saturn, but also reshaped our understanding of the interstellar medium, that faint, invisible ocean of plasma and radiation between the stars. But now, a new mystery has emerged, one that has gripped the attention of the scientific world. Recently, Voyager 1's instruments made a stunning and unexpected detection. 500 unknown objects silently drifting through the cosmic abyss. These objects, each traveling independently, appeared suddenly on the spacecraft sensors, an anomaly that has left scientists both thrilled and perplexed. What are these mysterious travelers? Are they fragments of ancient celestial bodies? Are they particles from an interstellar storm? Or could they be something even more extraordinary? Phenomena never before observed by humankind? The discovery has triggered a wave of research and speculation. Teams of astrophysicists around the globe are now analyzing the data, trying to decode the origin and nature of these cosmic phantoms. What makes this even more compelling is the environment in which these objects were detected. Deep within the interstellar void, far beyond the influence of our sun. This region is colder, darker, and more mysterious than any Voyager has ever encountered. It is a place where gravity is weak, light is scarce, and time seems to slow. Some experts suggest that the objects could be dust particles or icy fragments drifting from an ancient, distant collision. Others believe they might be remnants of interstellar comets, or even signatures of unknown forces at work in the vast architecture of space. Yet a few daring voices in the scientific community have raised a more controversial question. Could these 500 objects be artificial in nature? While there is no concrete evidence to support this idea, the mere possibility is enough to reignite age-old questions about life beyond Earth and whether we are truly alone in the cosmos. For now, the mystery remains. Voyager 1, ever silent, continues on its eternal voyage, a lone sentinel carrying the hopes and questions of humanity. As we await further analysis, this discovery reminds us of a powerful truth. The universe is far stranger, more complex, and more beautiful than we can yet comprehend. With every signal Voyager sends back to Earth, it extends the horizon of human to wonder what lies beyond. So, stay tuned as we continue to follow this unprecedented chapter in the Voyager legacy. For in the endless black of space, new secrets are always waiting to be uncovered. And sometimes, the most astonishing stories are written not in ink, but in stardust. Voyager 1's enduring mystery and the Tyson revelation. The revelation of the 500 mysterious objects detected by Voyager 1 has sent ripples through the scientific community. But the intrigue reached an entirely new level when it caught the attention of one of the world's most recognizable voices in astrophysics, Neil deGrasse Tyson. Known for his ability to translate cosmic wonders into captivating insights, Tyson has publicly acknowledged this finding as a landmark moment in the narrative of space exploration. These unidentified entities challenge our long-held assumptions about what exists in the remote expanses of interstellar space. They represent a new class of phenomena, not fitting neatly into the categories that scientists have spent decades constructing. Are they natural? Are they the remnants of an ancient event? Or are we seeing something never before imagined? Yet, beyond the mystery of the objects themselves, lies another astonishing truth. Voyager 1 is still functioning. Launched nearly half a century ago, the spacecraft continues to relay data across billions of miles. This resilience is not just remarkable, it's unprecedented. In an age where modern electronics are designed with obsolescence in mind, Voyager 1 stands as a monument to engineering brilliance and robust foresight. One of the key reasons for this longevity lies in its onboard architecture. Voyager was equipped with redundancy, a survival trait often overlooked in today's fast-evolving technology landscape. It possesses dual command computer subsystems, including the Fly Data Subsystem, FDS, responsible for processing and formatting scientific and engineering data. The Attitude and Articulation Control Subsystem, AACS, managing orientation, stabilization, and communications alignment with Earth. This duplication of systems enables automatic failovers, meaning if one system degrades, another can be activated, even after years of dormancy. This strategy has been crucial in preserving the spacecraft's operational integrity, especially as it endures the harsh conditions of interstellar space. Despite the age of its 1,970 Sera circuitry, Voyager 1 continues to defy the odds. Its systems, though primitive by modern standards, are incredibly durable. Each signal it sends is a triumph over time, distance, and entropy itself. As we contemplate the implications of this new discovery, we are reminded of the enduring legacy of Voyager. It is not only revealing the mysteries of the cosmos, but also highlighting the limitless potential of human ingenuity. In a universe defined by change and uncertainty, Voyager is a constant, a silent traveler speaking across time, urging us to keep asking, keep seeking, and never stop wondering. Power, precision, and the lifeline of the cosmos. In the harsh and unforgiving expanse of interstellar space, power management is not just important, it is pivotal to the survival of Voyager 1. With a finite and steadily dwindling onboard energy source, every watt counts. As the spacecraft journeys farther from the Sun and deeper into the abyss, preserving power has become an intricate balancing act. To sustain operations, NASA's engineers have employed a series of ingenious strategies. Through a process known as selective power reduction, non-essential components and subsystems, those not critical to the mission's core scientific functions, are systematically deactivated. These are tough decisions. Every system switched off means less capability, fewer instruments, and sometimes lost opportunities. But it's a necessary compromise in the pursuit of longevity. This strategic conservation is guided by one core principle: maximize science with minimal power. The spacecraft's remaining instruments are carefully prioritized, ensuring that it can continue transmitting priceless data from regions of space never before explored by humankind. But even with functioning systems, Voyager 1 is only half the story. To receive its signals, faint whispers from a spacecraft now nearly 15 billion miles away, we rely on an equally remarkable Earth-based counterpart, NASA's Deep Space Network. The Deep Space Network is humanity's cosmic lifeline, a vast communication infrastructure that allows us to stay connected with spacecraft, journeying across our solar system and beyond. This high-tech web consists of massive radio antennas strategically positioned around the globe, including Goldstone, nestled in the arid expanse of California's Mojave Desert, Madrid, Spain, and Canberra, Australia. This triad ensures that no matter Earth's rotation or Voyager's position in space, at least one station is always within reach to listen for the spacecraft signal and to transmit instructions. These towering antennas, some measuring up to 70 meters in diameter, are marvels of engineering in their own right. They're capable of detecting signals that arrive with less power than a billionth of a watt, equivalent to the energy of a falling snowflake. And yet, with incredible precision, they continue to capture data from the edges of interstellar space. As Voyager 1 continues its journey, each byte of data it sends is the result of a delicate interplay between onboard power efficiency and Earth-based technological excellence. It is a story of resilience, adaptation, and relentless pursuit. A story powered by innovation and connected by a global network that refuses to let our greatest traveler be forgotten in the void. Signals across the stars, communication and cosmic mysteries. To ensure uninterrupted communication with spacecraft like Voyager 1, even as Earth spins on its axis, NASA's Deep Space Network, DSN, relies on a triad of global facilities. These include Madrid in the heart of Spain, Canberra in the vast landscapes of Australia, and Goldstone in California's Mojave Desert. Together, these sites form a global listening post, maintaining round-the-clock coverage of our deep space emissaries. At the core of each DSN site stand colossal radio antennas, towering marvels engineered to capture the faintest whispers from the cosmos. These massive dishes are the literal ears through which humanity listens to the universe. Through them, radio waves carrying precious scientific data travel between Earth and spacecraft across billions of miles. Though these transmissions move at the speed of light, the immense distance between Earth and Voyager 1 introduces a unique challenge: a 22-hour delay for signals to reach the spacecraft and another 22 hours for a reply to return. In total, every exchange takes nearly 2 full Earth days. This significant delay demands meticulous planning and precise execution from mission control. Every command must be perfectly calculated, tested, and transmitted with zero margin for error. A testament to the skill and patience of the teams guiding this interstellar mission. And just when we thought Voyager 1's journey had settled into predictable patterns, it presented the scientific community with an astonishing discovery. 500 mysterious, unidentified objects traversing the cosmic void. These enigmatic entities, never before encountered or catalogued, have captured the imagination of both scientists and the public. What are they? Natural phenomena? Cosmic anomalies? Or something else entirely? One thing is certain: these objects have reignited the spirit of curiosity and wonder that launched Voyager 1 in the first place. As we peer deeper into the unknown, the cosmos continues to surprise us, reminding us that the final frontier still holds secrets we have only begun to uncover. Voyager 1, enduring spirit in the cold silence of space. One could argue that these unexpected discoveries are not just anomalies. They are a testament to Voyager 1's extraordinary legacy, a mission that has far surpassed its original scope. Each new revelation serves as a reminder of humanity's unyielding curiosity, the same force that dared to send a small probe into the abyss, chasing questions bigger than ourselves. Voyager 1 continues its journey billions of miles from the Sun, where solar energy becomes increasingly scarce. To adapt to this harsh environment, NASA engineers have developed sophisticated power management strategies. These aren't just about conserving energy, they are about evolving with the mission. In addition to carefully turning off non-essential systems, a process known as selective power reduction, engineers have implemented adaptive techniques that dynamically respond to Voyager's environment. These strategies prioritize critical instruments and communications, ensuring that even as the spacecraft's power supply dwindles, it can still beam back data from the cosmic frontier. Over the decades, there have also been technological refinements in how Voyager's limited energy is distributed. Improvements in power flow, more efficient circuit routing, and even reprogramming from billions of miles away have allowed NASA to extend the mission's lifespan far beyond expectations. Even the spacecraft's aging batteries, now operating under conditions never anticipated during their design, have outperformed all projections. Through a combination of foresight, adaptability, and sheer ingenuity have kept Voyager 1 alive, a beacon in the dark, still whispering secrets from the stars. Voyager's lifeline: power, precision, and the deep space network. Thanks to continual advancements in charging systems, power regulation, and control mechanisms, Voyager 1 remains a marvel of endurance. Engineers have spent decades fine-tuning every watt, every surge, every current, stretching the lifespan of systems once never meant to last more than a decade. Through these innovations, Voyager 1's epic scientific odyssey continues across the silent, infinite reaches of space. But power alone isn't enough. To make sense of the data Voyager collects, to hear its distant voice, we rely on a remarkable network here on Earth, NASA's Deep Space Network, or DSN. This colossal system of global antennas is humanity's ear to the cosmos, a technological marvel that connects us to spacecraft hurtling through deep space billions of miles away. Strategically positioned across the globe in Goldstone, USA, Madrid, Spain, and Canberra, Australia, the DSN ensures that as Earth rotates, at least one massive antenna is always in range to catch Voyager's faint signal. These radio waves traveling at the speed of light still take over 22 hours to reach us. That means any command sent and any data received must be planned with incredible precision and patience. Through this carefully orchestrated dance of power management and interstellar communication, Voyager 1 continues to do what no other spacecraft has ever done: explore the great unknown and send home whispers from the edge of forever. However, the role of the Deep Space Network, DSN, extends far beyond simply transmitting data. It also functions as a powerful platform for conducting radar and radio astronomy observations, allowing scientists to peer deeper into the cosmos and unravel some of the universe's most profound mysteries. What truly sets the DSN apart is its spirit of global collaboration. It works hand in hand with other space agencies and their networks, including the Soviet, Chinese, Indian, and Japanese deep space networks, as well as the European Space Agency's tracking facilities. This international cooperation forms a united front in humanity's collective quest to explore and understand the wonders of space. The DSN itself is composed of three main communication facilities, each strategically positioned about 120 degrees apart around the globe. These sites are located in Goldstone, California, Madrid, Spain, and Canberra, Australia. This global arrangement ensures continuous communication with distant spacecraft as the Earth rotates, maintaining an unbroken connection to the farthest reaches of our solar system and beyond. Located in California's Mojave Desert, Madrid, Spain, and Canberra, Australia, this strategic geographical arrangement ensures uninterrupted coverage and communication with spacecraft, even as our planet continuously rotates. Because of this global network, the Deep Space Network, DSN, stands as the world's most expansive and advanced scientific telecommunications system. At the heart of the DSN's communication capability are its colossal radio antennas stationed at each facility. These towering antennas act as vital conduits, enabling radio waves to travel vast distances between Earth and distant spacecraft. When data is transmitted from a spacecraft back to Earth, the DSN often uses channel 18, which operates on frequencies of either 2.3 GHz or 8.4 GHz, ensuring clear and reliable communication across billions of miles. Conversely, when sending signals from Earth to Voyager 1, a frequency of 2.1 GHz is used. Despite the incredible speed of radio waves, it still takes approximately 22 hours for a signal to reach Voyager 1. This significant time delay presents unique challenges for mission control teams, requiring meticulous planning and precise execution of commands. Any errors or unexpected issues can lead to further delays and complications, especially during the investigation of anomalies like those Voyager 1 occasionally encounters. Moreover, this communication lag limits real-time control and interaction with the spacecraft. Unlike missions closer to Earth within our solar system, where time delays are minimal, the vast interstellar distances introduce substantial communication delays. As a result, instantaneous conversations or quick adjustments based on real-time observations are simply impractical. Yet, despite these challenges, the Deep Space Network stands as a shining example of human achievement in space exploration. It is a testament to our capacity to overcome vast cosmic distances and gradually unravel the universe's secrets, one data transmission at a time. Resolving this particular anomaly required a meticulous process of troubleshooting and corrective action. After extensive efforts and numerous back-and-forth communications with Voyager 1, mission teams finally identified the source of the problem. The issue was traced to the spacecraft's command and control subsystems, which are responsible for receiving and executing instructions sent from Earth. Further investigation revealed that an unexpected electrical surge had occurred within these subsystems, disrupting normal operations. This electrical surge triggered a cascade of unintended actions within Voyager 1's onboard computer systems. As a result, the spacecraft generated and transmitted a peculiar message back to Earth, one that initially baffled mission teams. The surge had temporarily disrupted normal operations, causing a chain reaction of events that culminated in this intriguing and unexpected situation. In response, engineers and mission controllers at NASA's Jet Propulsion Laboratory sprang into action, working tirelessly around the clock to diagnose and resolve the anomaly. Their approach involved developing a carefully coordinated plan to reset and restart the affected command and control subsystems. This procedure was delicate and required precise timing and coordination to ensure that the spacecraft's vital systems could safely return to their normal, stable state without risking further complications. The successful resolution of this anomaly stands as a powerful testament to the incredible expertise, dedication, and problem-solving skills of the teams managing Voyager 1's mission. Their ability to troubleshoot and correct such a complex issue at an unimaginable distance, nearly 15 billion miles from Earth, demonstrates the remarkable human ingenuity behind deep space exploration. Moreover, this episode highlights the formidable challenges inherent in venturing beyond our solar system. In the harsh and unforgiving environment of interstellar space, unexpected events like electrical surges or system malfunctions can arise without warning, often due to extreme cosmic radiation, temperature fluctuations, and the sheer isolation of the spacecraft. Such conditions test not only the resilience of the spacecraft itself, but also the ingenuity and resolve of the engineers and scientists tasked with its care. As Voyager 1 continues its relentless journey through the cosmic abyss, this incident serves as a poignant reminder of both the fragility and resilience of human technology when pushed to its limits. Despite decades of travel and numerous obstacles, Voyager 1 remains an enduring symbol of human curiosity, perseverance, and the relentless pursuit of knowledge about the universe beyond our small blue planet. As Voyager 1 continues its epic journey through interstellar space, it stands as a powerful symbol of humanity's enduring spirit of exploration and discovery. Launched in 1977, this spacecraft has far surpassed all initial expectations, consistently delivering groundbreaking insights into the cosmos. Despite facing numerous challenges throughout its decades-long mission, including the recent anomaly, it remains a shining testament to human ingenuity and our relentless quest to unravel the mysteries of the universe. Voyager 1 has defied all odds, operating well beyond its original designed lifespan. Its remarkable longevity reflects the skill, dedication, and foresight of the engineers and scientists who crafted the spacecraft and continue to oversee its mission. Since its launch on September 5, 1977, Voyager 1's primary objective was to study the outer planets of our solar system, but its legacy has expanded far beyond this initial goal. Voyager 1's original mission focused on exploring the outer planets of our solar system, including the magnificent gas giants Jupiter and Saturn. Launched in 1977, the spacecraft embarked on an ambitious journey to study these distant worlds up close. Its encounters with Jupiter in 1979 and Saturn in 1980 stand as some of the most significant milestones in the history of space exploration. During these flybys, Voyager 1 transmitted to Earth an unprecedented wealth of images and scientific data that transformed our understanding of these massive planets and their complex systems. Voyager 1's discoveries were nothing short of revolutionary. It uncovered previously unknown moons orbiting Jupiter and Saturn, revealing that these planets were accompanied by rich, dynamic satellite families. The spacecraft also captured detailed views of intricate ring systems encircling both planets, structures that were far more complex and varied than scientists had ever imagined. These insights reshaped planetary science, deepening our knowledge of the formation, composition, and behavior of giant planets and their environments. Following its successful planetary encounters, Voyager 1 continued its voyage outward, eventually crossing the boundary of our solar system and entering interstellar space, the vast, largely uncharted region between the stars. This achievement marked a historic first. Voyager 1 became the very first human-made object to venture into interstellar space, a testament to human curiosity and technological ingenuity. Its instruments continue to send back valuable data about the properties of this mysterious region, including the interstellar medium's magnetic fields, cosmic rays, and plasma waves. One of Voyager 1's most enduring legacies came in 1990, when the spacecraft captured one of the most iconic images in the history of astronomy, the famous pale blue dot. At the request of astronomer Carl Sagan, Voyager 1 turned its cameras back toward Earth and took a photograph from an extraordinary distance of about 3.7 billion miles. In this image, Earth appears as a tiny, fragile speck suspended in a sunbeam, barely visible against the vastness of space. The pale blue dot serves as a humbling and powerful symbol of the fragility and uniqueness of our home planet. It reminds us of the singular place we occupy in the cosmic vastness, urging humanity to cherish and protect our delicate world. This poignant perspective, captured by Voyager 1, continues to inspire reflection on our place in the universe and the shared responsibility we have toward Earth and its future. Voyager 1's extraordinary journey through the solar system and beyond has yielded invaluable insights, not only about distant planets, but also about the very nature of our Sun and its expansive influence. Throughout its mission, Voyager 1 has been a vigilant observer of the solar wind, a continuous stream of charged particles emitted by the Sun and the heliosphere, the vast bubble-like region of space dominated by the Sun's magnetic field and solar wind. One of the most remarkable milestones in Voyager 1's mission came in 2012, when it crossed the heliopause, the boundary where the solar wind slows down and meets the interstellar medium. This crossing marked Voyager 1's historic entry into interstellar space, a realm far beyond the reach of our Sun's direct influence. Since then, Voyager 1 has been providing the scientific community with invaluable data about the conditions that exist in this cosmic frontier. Its instruments measure the density, temperature, and magnetic properties of interstellar plasma, giving us our first close-up glimpse of the space between stars. Perhaps one of the most astonishing aspects of Voyager 1's ongoing mission is its ability to maintain communication with Earth despite the staggering distance, over 14.5 billion miles away. This communication is made possible through NASA's Deep Space Network, DSN, a global array of massive radio antennas that act as a vital bridge between the spacecraft and mission control on Earth. The signals Voyager 1 sends travel at the speed of light, but still require more than 21 hours to reach us. This time delay underscores the immense challenges and scale involved in deep space exploration, where even light takes nearly a full day to traverse the vast gulf between Earth and the spacecraft. Recently, Voyager 1 experienced an intriguing anomaly that captured the imagination of scientists and the public alike. The spacecraft transmitted a mysterious and unexpected message, leading to widespread speculation and curiosity. While some entertained the idea that this might be an intentional communication attempt or a cryptic signal from the far reaches of space, the truth is more grounded in the complexities of operating a spacecraft far beyond its intended lifespan. NASA's engineers and mission controllers promptly sprang into action to investigate the cause of this anomaly. Through meticulous troubleshooting and careful analysis, they determined that the unusual message was the result of a temporary electrical surge in Voyager 1's command and control systems. This surge caused a brief disruption in the spacecraft's normal functioning, leading to the transmission of the unexpected signal. The dedicated teams at NASA's Jet Propulsion Laboratory worked tirelessly to reset and restore Voyager 1's systems, ensuring the spacecraft continued its invaluable scientific mission. This incident serves as a powerful reminder of the immense technical challenges involved in deep space missions. Voyager 1, now more than 4 decades old, operates in the harsh environment of interstellar space, where cosmic radiation, extreme temperatures, and the vast distances from Earth continually test its resilience. Yet, it remains a symbol of human ingenuity, perseverance, and our insatiable desire to explore the unknown. Voyager 1's journey is far from over. As it continues to sail through the interstellar medium, it carries with it humanity's hopes, curiosity, and legacy, transmitting data that deepens our understanding of the cosmos and inspiring generations to look up and wonder about the universe beyond our small blue planet. The recent anomaly, transmitted by Voyager 1, sparked widespread speculation and fascination. Some entertained the thrilling possibility that the mysterious signal could be a form of communication from an advanced extraterrestrial civilization, an unprecedented breakthrough in humanity's search for cosmic neighbors. While such a scenario captivates the imagination, the most plausible explanation, grounded in technical reality, was an electrical surge within Voyager 1's command and control systems. This surge temporarily disrupted the spacecraft's normal operations, causing it to send an unexpected and peculiar message back to Earth. This incident brought to light the immense challenges and complexities involved in managing and operating a spacecraft on such an extraordinary interstellar journey. Voyager 1, launched over 4 decades ago, was never originally designed to travel this far or last this long, yet it continues to function in one of the most hostile environments imaginable. The spacecraft's aging electronics, exposure to intense cosmic radiation, and the sheer distance from Earth all combine to create a uniquely difficult operating environment that demands constant vigilance and expert care from the dedicated mission teams. In conclusion, Voyager 1 stands as a towering symbol of human achievement and the enduring spirit of exploration. Its mission, which began with the goal of studying the outer planets of our solar system, has transcended all expectations to become an unprecedented voyage into the interstellar unknown. Through its incredible longevity and resilience, Voyager 1 has delivered an extraordinary wealth of scientific knowledge, profoundly expanding our understanding of the solar system and the vast universe beyond. More than just a scientific instrument, Voyager 1 is a testament to the ingenuity, dedication, and relentless curiosity of the engineers, scientists, and visionaries who have guided its journey over the decades. As it ventures deeper into interstellar space, Voyager 1 reminds us that the boundaries of human exploration are limited only by our imagination and determination. It embodies the boundless possibilities that lie beyond the familiar confines of our solar system and serves as a beacon, inspiring future generations to pursue the mysteries that await us in the cosmos. Voyager 1's Odyssey invites us to reflect on our place in the universe, a tiny speck suspended in the vast cosmic sea, and challenges us to continue reaching outward, seeking answers to the profound questions about existence, life, and the nature of the universe itself. The spacecraft's ongoing mission will remain a symbol of hope and discovery for years to come, a shining example of humanity's enduring